Hello everyone, how are you all? Welcome back to the channel again. I hope all are you good and learn something new with day by day. After a long time, a video will upload it on my channel. Actually, it's your channel because I'm a little bit busy on some other work like a membership program and some other work uh, related to my shop. But from now, I make sure a video, a learning video, will upload it on a right schedule so you get new learning. Thank you so much for your love and support to the membership program. Many people were joined the membership program and many people waiting for somehow they can't join the membership program for a YouTube policy. The reason behind the YouTube policy. And they were waiting and I hope something will be good in upcoming time. It will even better than this. So pray to God something new for you in upcoming days. Now, back to the topic. Today we discuss about something crucial or something important for mobile repairing field because the video uploaded after many days. So I thought make a good video for my subscribers, for my members also. So they all can benefit from this. So today we discuss about the diagnosis the dead phone through DC power supply, as you already seen in thumbnail. So how the dead phone repair, actually how to judge in a dead phone what type of the fault, which line causes the problem through DC power supply. I'll give you all explanation about DC power supply, what is DC power supply, how the DC power supply helps in diagnosis dead phone, each and everything, as I already giving all explanation in a depth in my previous videos, right? I'm not hiding anything. So I will give you all information about this topic, how to use a DC power supply. So I hope you will like this video and learn something new. Now, before going to the video, one thing important. Whatever I will give you readings about the DC power supply, how you use it's very current and ampere. I mean to say the readings can fluctuate or changes according when you changes the current and the voltage. It's also depend on the boot cable, what type of which company of boot cable you use. So it's a diagnosis purpose. It's just get you a clue what is the next work on. For confirmation, you can use your multimeter, your USB charger, ampere meter, the other tools. DC power supply for the confirmation, not exactly the confirmation. It's like a clue. So I hope you get my point, and let's go to the topic. How DC power supply work and how to diagnose a mobile phone with a DC power supply. Each and every detail. Now, it's your channel. Also, it's your responsibility to grow this channel. Watch the video without skipping properly. Also on a YouTube. This is a request, and you will follow. Watch only on a YouTube. So YouTube algorithm boost this channel. It's your channel. So I will bring more good content for you when this channel grow up. So I will bring more good content, more learning. So I hope you like this video. If you like, then like it, give a lovely comment and share this video. Now let's go to the topic and learn how to DC power supply work. So first of all, now important thing, don't be confused. Whatever DC you use, DC power supply you use, it's okay. Move on to the topic in front of you, there is a picture, right? A diagram. Whatever DC power supply you used, it's okay. But only a one recommendation for my side, used a 3 amp and above. I'm using this one. This DC is a 5 amp, right? Also a 31 volt, 5 amp DC power supply. So if you use 3 amp minimum, it's good for you. So if you use analog, digital, it doesn't matter. Now, what is DC power supply? Consistent DC current in output. First, a DC power supply is an electronic device, right? That provide consistent voltage and current in output, right? Whatever voltage you set in a output, suppose this DC power supply had 31 volt maximum, but if you set 4 volt, right, and 3 ampere, right, through this knob in output, right, when you measure with a multimeter on these output, right, you get exact 4 volt, 3 ampere. So whatever you set, it's generate exact voltage. Now first thing. Now second, powering up the devices. The DC power supply commonly used for the boot up, or you can say powering up the electronic circuits like your laptops, your mobile phones and the other circuits. Just connect the DC power supply to the device with positive and negative, and if your device is okay, it's boot up the device. I mean to say powering up the device. Now next, testing and troubleshooting. A DC power supply also useful for testing phones, especially in a dead phone or missing battery phones. Through DC power supply, you can identify the short circuit. Also, if you notice the current behavior, right, you can observe whether the fault is a major fault or normal fault. Like if the current behavior is a normal booting, so you can decide it's a normal fault. If the current behavior is abnormal, so then it's a count in a major fault. I will share with you whole detail. So stay continue. Sometimes a learning is also important. A theoretical part is also important, right? If you strengthen your theoretical part after the practical, I mean to say while on a repairing table, you do not need anyone. I mean to say you do not need any help from other persons, right? So strengthen your theoretical part. I know my video is little bit boring, but if you watch this video in a proper way, it will strengthen your theoreticals, your base, right? I hope you get my point. Now next, how it's help in a mobile phone repairing, a DC power supply, how it's help in a mobile phone repairing. Now first point, diagnosis in dead phones. When you connect the DC power supply with the control voltage and the control current, same except like a 4 volt and a 3 amp, right? When you connect a DC power supply with this current to the mobile phone, a motherboard, it's help the diagnosis first whether the phone is off or on without battery obviously. Also, if there is a fault in motherboard, right, or battery. Also look at the current or you can say ampere sequence. We get clue or you can say direction. Whether the fault in a CPU, power IC, a power rail, a secondary lines. So we get idea. So we can work on it. I hope this will also clear to you. Now after this, our next point, testing the short circuit. A DC power supply can identify the short circuit in mobile phone. I mean to say motherboard, right? By observing the current consumption. Let's example, if the higher current draw without pressing the power on off button. When you connect your DC to the motherboard and it's take auto consumption, auto current, I mean say auto reading, right? Without pressing the on off button, it's take current. That means there is a short circuit. If current consumption is high, then we call a full short. According to the current consumption, we can decide what type of the fault. Also, when you press the power on off switch, right, with no consumption, the fault, a secondary line, a MMC, a CPU does not respond. So you can get idea through the ampere sequence. I will share with you in this video whole sequence. Now next are short killer. A DC power supply also used as a short killer. DC power supply also find, you can say, through DC power supply you can find the short circuit, which component, which IC is a short on a motherboard with the Rosen method or IP, or you can say thinner method. For removing the short, it's also used. Now, after this, next, connecting the DC power supply. I mean to say, how to connect a DC power supply to your motherboard. Basically, there is a two main method to connect the DC power supply to the motherboard. First, direct current, right? For this, if you are a beginner, then you can watch. If you are a like some experience, you can skip this. First, through multimeter, you can identify which pin is positive and which is negative. So, multimeter probe you can connect here. Also, a banana probes. So, you can positive, red on a positive and black on a negative. Also, you can find a TP through this line on a positive must be a TP on a motherboard. Like some of the points near the battery connector or the charging connector. So you can find which point is a VBAT, right? It's connecting to the multimeter. Oh, sorry, positive line. For this multimeter on a beep mode, one probe on a positive and check one by one. Whatever pin beeps like this one. So this is a VBAT. So you can take a jumper from here, connect a jumper and jumper from the outside, connect with the positive line, this jumper, and ground at the black prop somewhere in any shield in motherboard. After that, press the on off button, find the short circuit. I mean to say diagnosis the phone. So this is the one way. But in model phone, we use another way. I'm telling you, call boot cable, right? Now in market, you will see these type of a boot cable with a different of connectors attached. Basically, a special cable designed for connecting the DC power supply to the phone motherboard. Because in modern phones, you will see there is another pins in a battery connector called BAT thermal, BAT ID, right? In some phones, SDA and SCL. We just talking about right now BAT ID and BAT thermal. So in this line, thermal and ID line identification, there is a circuit, right? on a motherboard. Also, if you open the battery VMC circuit, there is a circuit. So that's why this boot cable design, because in a boot cable you will see a two resistance in the top side of this cable connected, one for thermal line, one for bat ID line. So divider circuit complete, because in some phones your master IC or program like, if the bat ID line or you can say thermal line divider circuit complete after the CPU, your master IC sense, and then your phone boot up properly, mostly in a bat ID like battery identification, when your CPU sense the battery is there or not. If you direct connect positive and negative, and this sense circuit does not respond to the CPU, your phone must be on a restart mode. I mean, say it's not turning on properly, not boot up properly with the DC power supply. Through this cable, circuit complete. So that is why. But there is also some kind of problems I will share with you. First, talk about the boot cable. Now, in a boot cable, you had get 15 to 16. Just clear this. In boot cable, you get 15 to 16 multiple pins, right? For the Android, because in Android phones there is there is a huge list, or you can say many phones. So through this you can connect any phone most probably to these connectors, whatever the connector comfortable, or you can say compatible to your motherboard, like look like a battery connector. So you can attach it, and after that you can diagnose your phone or powering up your phone. So if there is a short circuit, you can find the short circuit after connecting this. If there is a fault in a secondary line, you can observe the current behavior, right? So that's why we use a boot cable, because there is a circuit, a separate circuit, right? Two resistance on a back strip on every connector. Now clear this. Now next. Now what is the boot cable problems? As I already told you, mobile phone there is a bat ID and a thermal line. Also, in a boot cable, there is a two resistance for circuit completion. For the circuit complete, right? As like in your battery, there is also a two resistance. But the issue with the boot cable, but the issue is here with the boot cable. There is a 15 to 16 connectors, right? On a boot cable, company claims this connectors work on a 4,000 phones. 4,000 plus phones. So suppose this connector work on a almost 200 phones, 200 plus phones. Suppose through this connector, if you boot up the any phone with a different company, it's not boot up the every phone, because every phone had a different circuit. For example, in a single company, let's say, and took any company with a different model in ID line or thermal line, if one company use one company, if any model use, let's say, 50K resistance, other used 100K, so there is a difference, because R2 in a battery, a divider circuit output a difference. So that's why some of the phones, when you connect with the boot cable, also not turning on, these kind of issues. When you connect with the battery and power up the phone, it's completely on. But same when you try to boot up with the boot cable with compatible connector, but it's not turning on, because the circuit mismatch. I hope you get my point. Let's again. There is a two resistance in a backside on this strip, right? One for the ID, one for the thermal. Suppose one company, or in any company, two models, right? In one model, you get a 50K resistance. right? In another model, company use 100K. So there is a difference, right? Now in a boot cable, you used 50K LEDs. So whatever the phone, a same circuit, that phone turn on with the boot cable with the compatible connector. But when the circuit mismatch, when you try to turn on your phone, it shows something 30, 40 milliamp, 60 milliamp. After when you release the power on off button, it's back to the 0 0. So you think there is a secondary line short CPU problem. But when you try to turn on with the battery, your phone working well, turn on properly. So these kind of issues from the boot cable, right? So try to use a BNC circuit, right? A battery flex. It's more better. Also, you get a better reading. I mean to say, your reading, observation, clarity far better for using these cables, because sometimes we also confuse according to this cable. While we use or this cable, suppose there is a battery is not working or battery low, when we use this type of the cable, and if it's shows a fake current, right, it's not compatible, the circuit not compatible with the phone, and it shows a different current, a fake current. So we confuse whether it's right or wrong. So as I already told you in a starting, for the confirmation, do not rely on a one tool. Do not rely like one tool on a DC machine. After that, your multimeter. After that, your USB ampere meter. After that, your DSO. So whatever tools you had on your counter, use this along with that DC power supply. So that will be the correct decision for you. I hope you get my point and you will understood. Now next. Now DC power supply channels. Now these are the channels M1, M2, M3, M4. Right? There are four channels in this DC power supply. I'm using this one, right? So whatever the channel setting I'm applying in my DC, I will share with you. Right? Now first 4 volt 3 amp in M1. I'm using this one to turning on the phone. Whenever a phone come to me, I'm testing diagnosis with this through boot cable or BMC circuit, whatever I have. Right now, second 4.2 volt 5 amp. Sometime I'm using this also with the multimeter probe. I'm using multimeter probes. Right, if I found a short circuit in a primary line, then I'm using this one attached with the multimeter probe. That's on a 5 amp, and we find the short in few seconds. Right now, next 2 volt 3 to 5 amp. First using 3 amp, after 4, after 5. This one I'm using for the like many lines had 1.8 volt or 2 volt, a shorting in a secondary lines. So if there is a many capacitors or filter capacitors or like 1.8 line also goes to the many sections, right? So find the short circuit, right, on a 1.8 voltage line. I'm applying this, but the ampere according to the first three, four, five. Whatever I will reading share with you. It's when you change the channels, it's different for you, right? Now next DC power supply readings. Let's talk about the readings. How the readings work in a DC power supply. How can you take a judgment or you can say get a clue? So which direction you can work, right? So same as I already told you, these readings just for the clue, not for the confirmation exactly there is a fault and which line is a fault, right? So you can confirm with the other tools. So a DC power supply reading. The first one, when you set a DC power supply, right, and connect with the motherboard on a battery connector, it's boot up 40, 50, 100, 140, 170, 250. When you release the power button, right, after that it's back to the zero, right? Same way. That means in some phones, your DC or your boot cable, obviously you connect with the boot cable, right? This boot cable does not compatible. See, if the circuit, let's say the battery ID circuit, identification circuit, does not work, in some time you get a restart, like a reading, because the circuit does not compatible. So it shows a fake reading. When you connect your battery to the phone and turning on, if your phone is okay, then it's turn on. But with the boot cable, it's not turn on. It shows these type of the readings. Sometimes it goes back to the 100 and then goes back to the zero. Sometimes it's boot up 140, 170, sometimes 140 and back to the zero. Also in your mind, one thing, the boot cable doing is also a major role in a diagnosis, right? Suppose a phone come to you, there is a low battery, and you will see this reading. And according to the reading, you can work on your CPU and find the shorting in secondary line. But when you charge your battery, suppose in phone, a charging issue, let's say that's why the battery is drop. So when you charge the battery, it's turning on. The issue in a charging section, but you can work on a CPU, MMC, and the secondary lines. So also remember the boot cable, also the impact. Now, when you connect a direct or positive to positive and negative to the ground, somehow this is not also the work because there is a not circuit complete. So remember this point always. Some phones does not boot up on a DC power supply. Why? Because a single connector compatible around 150 plus models, but the circuit doesn't match, right? Each and every model. So whatever the models, circuit complete, that's boot up. Otherwise, it's give you a fake result. So next, a full shot. The phone come to you in a full shot. How to identify? When you connect the DC power supply to the motherboard, if this current, let's say you set 4 volt, right, and 3 amp, right, now it's a 0 0 first when DC power supply off. After connecting exact, it's goes up to the 3 amp, 2 amp, right, and the voltage also drop 4 volt to 2 volt or 2.5 or 1.8 volt on this situation. That means there is a short in a primary line. We can call a full short. I hope you get my point. It's simple and easy fault. You can clear this fault in a simple way. Just apply the current like 4.2 volt and 5 amp and apply the Rosin method. Whatever the part, heat up. Try to feel with your fingers after you can apply the Rosin on which section there is a heat, and you can find the component, which component is faulty. So you can replace it, your problem is resolved. Clear? Now next, if your DC reading auto, let's say 10 to 400, or you can say 40 to 250, whatever reading shows, right, auto reading. First of all, these two are auto reading. In these two, we does not press the on off button. It's auto consumption. It's auto take where whenever you connect the DC power supply. After this, you can check the VPH line or V system line. Sometime you will see there is a 70, right? Or let's say 150. But when you go to the VPH, there is a full shot because in between VBAT and PA system, there is a DC to DC IC, DC to DC IC in a also a MOSFET on it. So sometime if shorting, major shorting on a V system line or VPH line, it's totally, or you can say completely does not pass on to the VBAT. You will see a little short here. But when you go to the V system line, VPH line, there is a full short. I hope you get my point. Now, before going to the next reading, I will show you something about this boot cable, right? This one. This boot cable used every technician. As I already told you, in this boot cable, there is a two resistance. Let me show you this. Now there is a two resistance on this side. Let's we go to the under the microscope, right? Now these two resistance, right? One for the bat ID and one for the bat thermal. These are R2 R2 resistance. Those people who know the divider circuits, in my previous videos, I discuss about the divider circuit. Already a special video on a divider circuit where I taught you how the divider circuit works. So R2 on a battery, right? On a mostly phones. So R2 connected to the ground. So this one, these two resistors connected to the battery ground. I will show you. So my multimeter on a beep mode. Now look at this strip. Now look at this. There is a two resistance similar. One for the bat ID, one for the bat thermal. Now these two resistors connected with the ground. These the positive pin right here. This one positive and other one the negative. So one probe on a negative. Let's say black. So black probe on a negative. And yes, beep here. So confirm this is the R2. R1 on a main motherboard. Now let's move on to the battery strips. Right now these are two battery strips on my hand. Right, we call a BMC circuit. Right here. Right, a BMC circuit. BN46, the battery number for Xiaomi. Now I will show you another thing. This is also a battery. Let me go to the main camera. So this connector BM46, right? BN46. Now the both strips, or you can say the both are same companies. What is the difference between both? Let's again go to the scope, under the scope. Now in this battery strip you will see there is a first positive nearby ID, thermal and negative. Remember, positive, ID, thermal, negative. Now look at here on a battery strip, positive, thermal, ID. Now again look at the strip from this one. Positive ID right here is a positive thermal. The circuit change completely. So this battery belong to this phone, right? Now, if I am connecting this strip, right, with the DC machine and connecting with the phone, this circuit will be work. Can you tell me? No, because the lines are changed, right? On a battery side compared to strip side, thermal ID replaces each other lines. I hope you get my point. So if the both companies batteries, even a same connector, you can connect this connector to the phone like here, connected, right? So even it's same companies, true batteries, same company, two strips, or you can say battery does not match each other circuit. Only if we check lines, thermal ID lines. So how can we rely on this boot cable? A boot cable give us a correct reading. If this strip does not give us a correct reading, I hope you can understood what I am saying to you. So anyone who will tell you, they will give you a correct reading. These readings, as I already told you, only for the clue. I need to say for the judgment. For the confirmation, you used other tools like multimeter, USB ampere charger, DSO, these type of the tools. So do not rely on a one tool. I hope you get my point. On a simple words, in Android phones, you do not rely on a one tool. These readings are working. Whatever I will share with you, but only those ones, those are compatible, right? Because if these this boot cable connected to 4000 plus models, clear, 15 16 pins attached with the 4000 plus model, only attached, not the compatible. This boot cable compatible some phones, and boot up the proper, I mean say turning on the phone, or those phones on programming like in a boot sequence, or turning on boot sequence, bad thermal or bad ID doesn't matter. If a programming on a phone like this, thermal ID, battery identification pin, is an important role play in a turning on phone, then if this cable does not compatible, you will get a fake reading. I'll give you a reading, but that doesn't mean you do not use other tools or mind. Now let's move on to the video again. Now next, when you connect the mobile phone and it shows 30 milliamp, 50, 60, right? When you release the power on off switch, it goes back to the 0, 0, right? Then it's must be shorting in a secondary line, or your CPU does not respond. Your power on, boot up, when it's given to the voltages, a buck voltage to the CPU, somehow the buck shorts, any LDO short. That's why it's back to the 0. When it's produced the voltages, a buck voltages for the CPU, CPU does not respond, and the feedback does not come from the CPU, and power shut down. Maybe something wrong on the circuit or with the CPU. When you try to switch on the phone, when you connect the DC power supply, it's take no consumption. When you press the on off button, it's take 30 milliamp, then 50, then 60, then 65. When you release the power on off button, it goes back to the 0. Again, you try again. The same result. That time you work on a secondary lines, output, the power IC output lines like buck lines, LDO lines, the VRAG LDO lines. On some time your CPU dry itself. That's why it's not respond in a drop down cases, because as I already told you, the power produce the buck voltages for the CPU. But if there is a shorting in a secondary line, it's also goes good back to the 0. If the CPU does not respond and feedback does not come to the power, it's the current also get back to the 0, because the power IC sequence does not hold a PS hold. Remember, when CPU properly respond, then power IC hold the all voltages, the buck voltages and LDO voltage. But if CPU does not respond or any shorting or leakage, power IC generate the voltages after It's shut down automatically, thinking something gets wrong, right? On a circuit. Now, next. Now, stuck. When you connect the DC power supply, no consumption. When you try to press button or on off button, it's take 50 to 120. Let's suppose in some phone 70 and reading stock 80 or reading stock 85 reading stock. These type of the issues you all must have noticed, right? Then the problem come from the storage IC called MMC, UFS, right? Mostly in MMC. Also the software, your firmware. When software corrupt or MMC health, also the MMC requirement, the voltage requirements and other requirements does not complete, your phone behave like this because your power IC boot, your CPU respond. But when it goes up to the on MMC, then CPU does not find the MMC, the reading stuck or maybe a software complications. So you can work on a MMC or software. Clear? Now next. Now in this case, when you connect the DC power supply and press the on off button, it's zero point 0.4 milli, 5 and 6. It's whether a fluctuate or stuck in between it. Then we can call a low booting. Sometimes a CPU does not respond to the power. So in this case, a low boot maybe so mostly chances in new phones are CPU, right? These readings are just observations. I'm again tell you, do not rely on it. Just take a clue. Now, there is no teacher who can say with a boot cable, right? Remind boot cable, who will give you a correct reading, 100% surety reading you can apply on any phone because the company changes, model changes, the reading accordingly also changes because whenever a power IC for a different model, after that another model, the sequence is a difference. So there is only for the judgment, right? Like a clue. I hope you get my point. I'm talking on a logic. If anyone who claim about the reading, I'm inventing this reading apply all the Android phones. It's not true. You can collect your data, right? I will tell you. You can collect your data. So observing the phones. How? If you had a batteries like replacement batteries, a bad batteries, just remove the BMC circuit on a charging flash, on a battery, right? A battery strip. Use as like a cable. I mean to say this BMC circuit used like a connector attached with the DC power supply. After you can measure the current. Whatever the data you collect, write it down in any diary copy. So these data are more reliable when you compare to the bootcamp. I hope you get my point. Now, next, if when your phone connect and it's goes to the 0.120 and to the 200, normal booting 30, 40 milliamp, 60, 120, 150, 180, back down to 120, 140, anywhere, stuck between anywhere. This problem caused to the RAM, a bad RAM voltages, RAM voltages, mostly in the double decker phones. RAM get dry because RAM attached with the CPU together in a two layers, upper layers RAM and downward the CPU attached together. So sometimes RAM dry. So these type of the issues create. Also sometime RAM attached with the MMC circuit combined. Nowadays, in some phones, RAM separately given by the companies. So if you see this type of the reading, so you can work on the RAM, complete the RAM circuit, the voltage requirements, the enables. Also, there is a RAM, a separate RAM, or on a double decker, change the RAM. Sometimes this problem goes to the CPU because if CPU does not respond to the RAM, a communication drop, same as like a MMC. Nowadays, the stuck problem also caused to the CPU because the communication loss between CPU and the storage IC or RAM IC, then you will see these stuck problems. Now, in next case, when you connect your phone to DC power supply, it's after the power on off button, press 0.04005 and back to the zero. This problem goes to the buck lines and LDO, right? Maybe a buck line short, maybe a higher LDO, lower LDO, or any LDO, a major LDO short. So work on this. Now, in some cases, you will see when you connect a DC power supply with a hood cable, it's stuck on 0.12 and 0.3 without pressing the on off button. This problem goes to the DC to DC IC, power IC, or the minor shorting in your primary line. Also remember, if sometime the resistance of the cable is also, if your cable is right, when you apply on other phones, it's goes to the 0 0, stuck not anywhere. That means it's okay. But in some phones, when you apply and show this type of the reading, directly connect to the 0 0 1, 0 0 2, and 0 0 3. That time you work on your DC to DC IC. Replace the DC to DC IC. Check the minor shorting on your primary line near about the DC to DC IC or power IC. Also, the power does not respond. I hope you get my point. So these are the readings I will share with you. Whatever readings you can use it, right? So I hope you like this video and it will get a benefit to you in a mobile phone repairing, maybe mostly in a dead phone repairing. So you can get a idea. So if you like this and learn something new, then like it, comment it, and share this channel with the other technicians. We will see you in a next another video with the new learnings. Thank you so much for your love and support.